It's okay if it is. I'll be chill. Alrighty, good morning everybody, and welcome to another live science virtual with Chabot Science Center. How's everyone doing this morning? Hopefully you're doing okay. My name is Haley and I am a science educator here at Chabot, and what live science is we do one fun, interesting, thought-provoking demonstration of a phenomena of science. And then we ask for your help to figure out what that phenomena is and what's going on. Now, what is a phenomena in science, you might think? Well, it's kind of like an occurrence or a happening or an interesting thing that you can repeat over and over again. And then we're going to break it down to actually try to figure out what's happening in that phenomena. So, are you all ready to help me out and be some scientists with me today? Hopefully you are. We're coming at you live here from Chabot Space and Science Center. However, during this time, Chabot is closed to the general public. We are working on our grand reopening in the spring of 2021. But in the meantime, if you would like to help support us in any way and help us provide free programming, such as our live science shows, which occur weekly, our public program virtual events, such as our Spooky Science Show, which is coming up at the end of October, and our free virtual telescope viewings, feel free to donate. We have a donate button if you are on Facebook Live with us today, and we also have our website, chabotspace.org, that you can go to and click the donate button if you would like to help support us during these times. Thank you in advance so much if you would like to donate, and hopefully we'll get to see you all soon. Now, if you're a teacher here joining us today or an educator, feel free to let us know that you're out there. We kind of want to know if we're reaching any teachers or educators with our live science program. So if you are a teacher joining us today, feel free to just let us know by typing into the chat your grade or that you teach, or maybe the subject that you teach, and then where you're coming from. If you're coming from California, or if you're coming from outside of California, just give us a quick little heads up and hello, because we want to figure out ways that we can help support you as teachers even better moving forward throughout the rest of the year. So quick shout out to all the teachers out there. Thank you for all the hard work, and let us know if you're here. Cool. All right. So we're going to get into our demonstration, and what this is we're going to be talking a little bit today about colors and the way that we perceive colors. So the way that we see colors using our eyes, but also our brains. And we're also going to be continuing our theme of October, which is light, because light helps us see colors, and colors are all thanks to light. So we're going to kind of continue on that journey talking about light and colors today. Alrighty, so let me get us ready. So what I'm going to do today is I'm going to hold up some different squares. These are different colored squares, and I'm going to need your help to make some observations of what you notice about these squares and the dots that we have on them. So I'm going to hold up two squares. Each has a dot in the center of it, and I want you to make some observations of those dots. And I want you to think about a few questions. So let's get started with our first set of dots. I'm going to put them up here. And I want you to take a minute and do a quick observation of these dots. And I would love it if you observed them and told me what you notice. So about these two dots, what do you notice? Do you think that these two dots are the same color? Do you think that they are different colors? What do you think? And why do you think that? So I'm going to give you a few seconds, probably about 30 seconds, to observe these dots and type into the chat what you notice about them, what color you think they are, and if you think they're similar or different. And I'll roll you forward, woo, so you can get a closer look at these two dots. So in the center, what do you think about these dots? Same color, different color, what color are they? And I have some coworkers here today. I have Jamal, who's one of our interns here at Chabot Space and Science Center reading out our chat on Facebook, and I have Lisa, who helps coordinate our overnight programs and helps out with education, on the other side, helping me read out our YouTube chat. So we have both chats being monitored to see what your responses are, whether you're a class or an individual. So let's kind of see if we got any responses so far.
We have Lucy saying that they are the same color.
All right.
And we have Jeanette saying that the center pink on both are also the same color.
All right, so both Lucy and Jeanette on Facebook, I believe, think that this pink circle, they think it's pink, looks the same color. So great observations. Thank you both for typing that in. I don't know if we have any on our YouTube chat yet. Lisa?
We have another answer saying that the yellow background has a pink dot, and the green background has a purple dot, so different colors.
So we have a different response saying that our yellow background has a pink dot and our green background has a purple dot. So a different response from a different viewer. Now, you may be looking at these, you may be thinking, are they pink? Are they purple? What are they? And what we're going to do now is check it out. So let's see. So I have a pink piece of paper that we're going to use to compare our two dots. So I'm going to hold it up here, and I want you to just make a quick observation. What do you notice when I hold up this pink paper? And I'm actually going to ask my friend, my coworker, Olivia, to come on over and hold this up for us. And I'm going to put my mask on so that we're being safe. All right, so now that we've held up our pink, we could slide it back and forth. What do you notice? Are they the same color dot? Doesn't look like it to me. When I first looked at these two dots, I thought they were both pink. But now that we hold this pink square up, this one looks much darker. Would you agree? Let's test that by, I have a purple sheet of paper that I'll hold up here. Now when we look at this, do these look the same color dots? Not so much. What do you think, Olivia?
They seem different.
Yeah, they seem different. So this one is a purple dot. It's much more purple, it's that dark color. And this one is a pink dot. It's got that light color. But when we remove our squares, they kind of look the same. Interesting, right? So think ahead and think again. If you want to try to explain, why do you think these two dots look the same when they are different colors in reality? So we're going to try that again, but with a different set of dots. So get your observations ready, get your chats ready. Go ahead, go. So now we've put up two different colored squares, and these colored squares have a dot in the center of them just like before. And I would love it if you could make some observations about those dots in the middle. I'm gonna put them down here. Is that better lighting? Yeah, we'll move them down just a little bit. All right, so based on these two squares, I'm a perfectionist, what do you think about these dots in the middle? What do you notice about them? Do you think they are the same colored dot, or do you think that they are different? And why do you think that is, or how do you think they're different? So go ahead and just type into the chat some observations that you might have about these two dots, just like we did before for the first two. And we'll give you some time. There's a little bit of a lag between us and you. So we're talking about colors.
Deanna, go to class in Canada, says they are different colors.
Nice, we've got a class all the way from Canada joining us, and we thought that the dots look like different colors. So they look slightly different.
I have two answers, actually three, saying that one is pink and one is red. I have another one saying that the one on the left is darker. And another one saying that one is purple and one is red. So people are giving a lot of different colors trying to figure out what's going on.
All right, we have a lot of different answers in the Facebook chat, slightly different. Some folks think that one is pink and one is red. Some folks thought maybe one is purple and one is red. We also thought that this dot in the green looks darker than this one over in the orange. So a little bit of a split here on our responses. and not always exactly the same. We've got one on YouTube saying the left is red, so this one, and the right is pink. All right, so a lot of people out there saying it looks different. Let's test it out the same way as before. I've got Olivia over here with our red piece of paper to test it. And when we hold up this red piece of paper, what do you notice? Let's move it forward a little bit. So what do you notice now that we hold up this red sheet of paper? They look pretty much the same to me. What do you think, Olivia?
They look the same to me.
Yeah, these are actually the same color red dot. They come from the exact same piece of paper. I would know because I cut them out yesterday. But this is the same color red on the orange square as it is on the green square. So this was the opposite of what we just saw before. In the first demonstration, our two dots that were different colors looked the same. And in our second demonstration, these two dots that are the same color looked different. That's curious, right? What do you think is going on here when we look at this interesting phenomena happening? Why are our brains telling us and tricking us into thinking two different colors are the same and two of the same colors are different? I want you to think about it, and I want you to type into the chat if you have a guess or an explanation or even just a hypothesis. What do you think might be going on here, and how would you explain this? Also, if you have an experience where something like this has happened to you before, go ahead and type it into the chat. A time where some colors looked different to you and it kind of tricked your eyes. While you do that, I'm going to put up a different color test. This time it's going to be 4 pieces of paper with 4 dots, 1 in each, and I want you to do the same thing. So do you think it's the same color, different colors? What do you think? I'll take these down and I'll have Olivia set up our next set of color demonstrations. Lots of dots today. Feeling dotty.
Deanna's class thinks their eyes are playing tricks on them.
Ooh, so Deanna's class thinks that their eyes are playing tricks on them? You're on the right track there. Your eyes are definitely kind of messing with you a little bit today.
And hoping the light is making them look different.
Ooh, so maybe the light has something to do with it? The light is making them look different?
We have an answer that's, I like this answer.
Ooh.
So Leah says perhaps the background colors are absorbing/reflecting different colors, so it is changing our perception on what colors are actually showing.
Nice. So Leah had a really good explanation. They said that the background colors might be absorbing or reflecting different types of light, which could be affecting the way that we see the dot in the middle. So something to deal with the background colors and the light that's bouncing or reflecting off of them, and the way we see the center dot. So these are all in the same general theme and area, and you're on a very, very good track. Especially those of you, feels like some of you may have tuned in to previous weeks, which if so, you might be recognizing some of the trends here. Any other good observations from our chats before we break down the science going on here?
A similar answer, but just saying the background colors are different, which makes the middle dots look different based on the contrast of the background colors.
Nice. So I heard a really good word in that explanation. We thought that the background colors are making the middle dot look different based on the contrast. So the word contrast can mean a difference. So you can contrast black versus white. Those are two very different colors. And if you put white font on a black background, the contrast, because they're very different, makes the white font stand out. So if we have something on a dark background, that might contrast heavily with a lighter color, but on a light background, that might contrast differently with that same color. So we're in a pretty good spot. And on this one of our 4 square, these are all the same color. So you may have already made that observation or figured it out, but this is our color purple. When I hold it up, it's the exact same here, as it is here, as it is here, as it is here. Even though when I remove it, some of these purple dots, like this one, looks kind of lighter to me, and some of them look darker, like this one looks darker to me. So what is happening here? Well, this all has to do with light and the way that light can actually play tricks on our eyes when we are perceiving the world around us. So when you're looking at the world around you, everybody take a minute, look around, take a big long sweep of your environment. You're using a tool, and the tool that you're using to see your environment is your eyes. Everybody point to your eyes, blink them, cross them, don't cross them, warm them up, whatever you need to do. So our eyes are a really important tool in looking around and seeing our world. But in order to actually see our world, we need light, because light that is bouncing off from our sun or the light in your room is bouncing off of the objects around you, and those objects are reflecting that light and dispersing it in many different directions. And if you're nearby, some of that light is going to go into your eyes. And then your eyes are going to perceive that light, and they actually kind of translate that light and send it to your brain so you get to see an image. So the way we see the world all has to do with the light that's around us, but also the way that our eyes are perceiving the light. Now, inside of your eyes, there are some really interesting cells. There's two different types of cells in our eyes. And these are cells that are sensitive to light. So what does that mean? Well, when I wake up in the morning, I'm pretty sensitive to light. If someone turns the light on, I'm like, oh no, turn it off, it's too bright, I don't like it, I don't want it. I'm sensitive to light. Now these cells in our eyes, they can detect light, they're really sensitive to it. So if any light hits those cells in our eyes, they are going to have some sort of signal, and they'll send that signal to our brain. Now in our eyes we have some cells which are called rods. Have any of you heard of rods before? If you have, you can type into the chat. What do rods help us see? And we also have cells in our eyes that are called cones. Have you heard of cones before? If so, type into the chat. What do cones help us see? So in our eyes, we have rods and cones. And you may have already known this, but rods help us see light, all types of light. And they can even detect low-level light. So if you've ever been in a really dark room before, like at night, and you look around and you can kind of see the room, those are the rod cells in your eyes that are sensitive to really low light. They're detecting that light, and they're kind of reading it and sending that to your brain so you can see around the room. Cone cells can also detect light. However, they allow us to detect colors in our light. So the cone cells in our eyes are what allow us to see all these different colors, like pink and red and green and orange. And when we have both of these working together, both rods and cones, they work together to give us the vision that we have. This is what allows us to see shapes of things, to see dimension, how far away something might be, to be able to see movement, which is all really important for survival in our world. You have to be able to see what's around you. Now, there's over 125 million of these cells constantly detecting light. So your eyes are one of the coolest tools you have. Except sometimes these rods and cones can play tricks on us. When we are detecting light in the world around us, sometimes the way that cones see light can affect one another. And this can lead to some tricky things. So, when cones are receiving light, sometimes it affects the other ones around it. So for example, let's pretend these are cones. This is my best drawing of a cone. We're going to say this is what cones look like in our eyes. So say these are all cones, and your cones see blue light in the world around you. So you look at a blue square. This cone that's detecting that blue light will then also trigger the cones around it, meaning all of these cones are detecting that blue light. What that means eventually, though, is that these cones in your eyes are less likely and less sensitive to blue light that you see past that. So when you look at a blue square with a green dot, your eyes are already seeing so much blue that when you look to the green dot in the middle, your cells are less likely to detect as much blue from this green dot in the middle. That means this green dot is going to have less blue in it to your eyes than it would if it was a green dot on its own. The same thing occurs if we were to look at yellow. If you were to look at a yellow square, the cones in your eyes are detecting yellow light, meaning that they are kind of tired. They're tired of looking at yellow light. So when you look at this green dot in the middle, you're going to see less yellow light coming out of this green dot than you would if the green dot was on its own. It's a little tricky, but it also has to do with our perception of it. So scientists think it's a combination of both these cells and the way that they interact in fire and how they can get a little tired of seeing some colors, but also our perception of it. Somebody mentioned contrast earlier. If we look at a green dot on a blue background and a green dot on a yellow background, by contrast, this green dot is going to look much brighter than a dark blue background, and it might look a lot darker when it's on a light background like yellow. So it's a mix of both the way that our cones and rods are perceiving what we see around us, but also our general knowledge and our experiences in the world around us. The way that we perceive contrasting shapes, shades, colors, and shadows can play tricks on our eyes to convince us we're seeing something that might not actually be there. So that's kind of why we see what we see, because of the background colors shifting and changing the way that we perceive the color in the middle of our squares. So that's pretty much it. In the end, color is just simply our perception of it. Is color even real? You can think about that. And sometimes the perception that we're seeing is completely up to the viewer. You noticed some people had different observations than other ones in our chat. So when we look at colors, it's always good to question what you're seeing and whether you're actually seeing what it truly is or if it's just a trick of light and color. All right, friends, we're going to turn to our question and answer. If you have any questions that you would like to type into the chat, if you have any burning questions you're really curious about color or light or the demonstration we did today, feel free to type them into the chat right now. And while you're typing them in, I'll just let you know about some of our upcoming events. So along with our live science show, which occurs every week from 10:30 a.m. to 11 a.m. on both YouTube and Facebook Live, we also have weekly telescope viewings that you can tune into on our Facebook page, Chabot Space and Science Center. And you can also tune into our virtual larger events. We have things like talent shows and variety shows. We actually have a spooky science show coming up this Friday, October 30th at 7 p.m. So if you'd like to attend our spooky science show, it's gonna get real spooky, so feel free to join us. I'll put this up here, just in case. And also, if you'd like to help support us and donate, feel free to head to chabotspace.org or click the donate button, and you can help support us in all of these free programs that we're trying to bring a little bit more science into the community during these times. And for any of those teachers out there, if you are joining us and you have a special story you'd like to share about how Chabot has helped you during this time or the impact that our virtual programs have had on you and your class, feel free to DM us on Facebook, or you can email us at info@chabotspace.org if you'd like to share a special story with us, because as I said in the beginning, we are working on some special programming and some special projects to find out ways that we can better serve you as educators and our larger community in Oakland as well. So that's kind of our pitch. I'm going to check in with our Facebook chat and our YouTube chat to see if we had any questions. No questions, just a thank you. Thank you for joining us. No questions from Facebook? Any questions from our fellow coworkers? All right, friends. Well, thank you for joining us for our optical illusion about colors today. And if you have any questions, feel free to let us know, but we will hopefully see you around, and we'll see you next week for our last light demonstration for the month of October. And then in November, we're going to move into some sound demonstrations. So that's the plan. Hopefully we'll see you out there. Stay safe, stay curious, get out and vote, do some good for something, make sure you're being a good human, do it. All right, we'll see you all next week. Thank you so much for joining us again, and we appreciate you.